Hi, today we're going to talk about risk assessment using hierarchy analysis, and for the case study we're going to discuss about an industrial incident. Risk assessment is the process of identifying hazard, analyzing the level of risk they pose, and applying appropriate control measures. It is crucial in industries such as chemical plants, construction, and manufacturing to protect workers and assets. A good risk assessment prevents accidents, ensures compliance with legal standards, and improves organizational reputation. HIRAT stands for Hazard Identification, Risk Assessment, and Risk Control, a structured method used in Malaysia and globally to manage workplace risks. Objective of this study is to systematically identify potential hazards within industrial operation, to assess both likelihood and severity of those hazards and classify the level of risk, to recommend effective control measures including engineering, administrative, and training interventions, to promote a proactive safety culture, ensuring that both management and employees take responsibility for workplace safety. Ultimately, the study aims to prevent accidents, protect human life, and maintain operational continuity.
On June 3, 2020, a devastating explosion occurred at the chemical factory in Gujarat, India. The accident caused 10 fatalities and left almost 50 workers seriously injured. The shockwave from the blast was so powerful that it required the evacuation of a nearby village. Root causes: incompatible chemicals, dimethyl sulfate and nitric acid, were mistakenly mixed, producing an intense exothermic reaction. This reaction built up extreme pressure inside the tank, which burst violently, resulting in a catastrophic explosion.
So now, let's look at the contributing factors that led to the explosion. Firstly, the worker responsible was only a contractual employee without proper training or certification. Secondly, there were no standard operating procedures or permit to work system in place during chemical handling. Another factor was improper labeling and lack of double verification, which caused confusion and led to the wrong chemical transfer. In addition, a hydrogen trolley was placed too close to the tank. When it ignited, it caused a secondary explosion. Finally, the company did not have a proper emergency response plan or conduct safety drills, which made the disaster even worse. Moving on to the HIRARC analysis. For the work activity of chemical offloading, the main hazard was mixing incompatible chemicals. This had a very high risk value of 25. The existing control was just basic tank labels, which was not enough. The recommended controls include SOPs, interlocks, alarms, compatibility charts, and also color-coded tanks. The second activity is handling by untrained workers. Here, the hazard was human error due to lack of training with a high risk value of 16. The existing control was only general induction, which again was insufficient. The recommended control should be mandatory training and certification, restricted access, and close supervision. From the findings, it is clear that this explosion was not caused by a single mistake, but rather by a chain of systematic failures. The management showed a weak safety culture where production was prioritized over safety practices. Storage of chemicals was also unsafe as they were stored based on availability instead of compatibility. In addition, the facility had no emergency response plans or safety drills, which made the response slow and ineffective. Overall, workers were poorly trained and lacked proper supervision, showing a major breakdown in both operational discipline and risk management.
Based on these findings, several recommendations are proposed. First, strict standard operating procedures, along with the permit to work system, must be enforced. All employees handling hazardous materials should undergo mandatory training and certification. Engineering control should be also introduced, such as automated interlocks, alarms, and chemical compatibility charts. Next, a clear labeling system should be implemented. For example, color-coded tanks with digital verification using RFID or barcodes. Hydrogen trolleys and other flammables should be relocated to safe designed storage zone. Finally, the organization must foster a safety-first culture by ensuring leadership, accountability, and active worker participation. In conclusion, the Gujarat chemical plant explosion demonstrated the devastating consequence of neglecting industrial safety practices. The accident was caused by multiple failures, including improper chemical handling, lack of worker training, poor supervision, and absence of emergency preparedness. High-rec analysis shows that such hazard could have been identified and controlled in advance. Therefore, organizations must adopt technician measures like automation and safe storage, administrative controls such as SOPs and supervision, and cultural commitment through training and leadership responsibility. Safety is not optional, it is a fundamental requirement to protect workers, community, and the environment.